Welcome to Semantic Web Technologies. This is Lecture 2, Semantic Web Basic Architecture, Part 1. In the last lecture, we have introduced the semantic web. We have talked about the problems that the current state of the World Wide Web has and how to make it better with the vision of semantic web technology. We have already introduced here the semantic web technology stack, and today we want to go deeper into the stack and to take a look at the basic technologies that are the fundament of the semantic web. And today we start with the question how to identify things, and we will be talking about uniform resource identifiers first. So, what is this? Of course you will say this is an apple. Another question. What is this? This is also an apple. So, is this the same like this? Good question, isn't it? The question is, what's the difference of all these apples? The nice thing of our human mind is that when we talk about things, we take into account representation of these things, and not the things necessarily itself. If we talk about an apple, everybody will have in mind an apple, but not a specific apple, but only an apple that has properties that are common to all apples. And this is how we talk about apples, how we understand the concept apple. So, we have seen this semiotic triangle already. When we talk about things, for example, we talk about an apple, then we have apple, the symbol, the word that I'm speaking. And this apple stands, of course, for an object of the real world, for the object you have seen in my hands. But on the other hand, if I'm talking about apple, in your mind, the concept of an apple, including all its general properties, occurs. And this is the way how we deal with things. We take into account representations of these things and not the things itself, if we talk about them. And then we might share a common concept, and on the basis of this shared concept, we are able to communicate information and to understand information. So what we have to do is we have to identify the things we are talking about. We need representations for these things also in the semantic web. And in the semantic web, we have the uniform resource identifier. So what does it mean? Uniform means we can identify different types of resources, and we have an identifier for that that is constructed according to a uniform schema. And it means we can identify almost anything. Any resource we can think of can be identified via a uniform resource identifier. And of course, this identifier must be suited to distinguish one resource from another resource in a unique way. Generally, in the web, a uniform resource identifier defines a simple and extensible schema for a worldwide unique identification of abstract or physical resources. And this all is laid down in the request for commands number 3986 and can be read there. So what you can identify with an URI is a resource of any kind, for example, web pages, but also books, locations, persons, relations among objects, abstract concepts, and stuff like that. And the concept of the URI is established now for a long time in the web via the so-called URL, the Uniform Resource Locator, which is an address of an object, of a document in the web, or, for example, also in the web with persistent resource names or persistent uniform resource locators. Books and publications can be identified via ISBN or ISSN numbers, and there's also a thing called digital object identifier to identify things generally in the web. So in the web, when we are talking about something, we must have an address for that. So for example, we have here a URI identifying somehow a resource that is related to the Eiffel Turm. And the representation of the Eiffel Turm or the Eiffel Tower in the web is, of course, the web page that contains information about the Eiffel Tower. So what we have is a web page. This is the presentation in the web, how you see it in the browser. And the metadata of that is the representation. It means this is the HTML web page that you can see on the web. And the browser translates this HTML into a presentation format that you can read as a human. So, if you want to access information about the Eiffel Tower, what you have to do is you have to send a request. Your browser will send a request to the address of the Eiffel Tower in the web and tells the server or the host that where the resource about the Eiffel Tower is located, what file should be retrieved, and which format should be accepted. So the communication goes a long way. It starts in your web browser. There, the HTTP request is sent. The HTTP request arrives at the web server, and at the web server, a response is prepared that contains the file representing information about the Eiffel Tower that is finally interpreted in your local web browser and displays the presentation of this web page. But, of course, you know that the presentation, it means the so-called designator of the web page or of the Eiffel Tower, is of course not the Eiffel Tower itself. It's not the real object. So there's a difference between the real object, which is the thing that is designated, the so-called designatum, and the thing that represents the real object, the designator. But as we have already seen in the example with the apple, we can talk about the Eiffel Tower simply with the help of a representation that we have here also on the web. So maybe you have seen this famous painting from René Magritte called La trahison des images. It means, ceci n'est pas une pipe. This is not a pipe. Of course, this is not a pipe. This is simply a picture of a pipe. It's the presentation or representation of an object. And we can talk about this object and we can treat this object like it would be the real object, the real pipe. It means, if we come back to our example from the start, ceci n'est pas une pomme. This, in French, is not an apple. It's simply a picture of an apple. So the nice thing is we can talk about objects or we can identify objects and distinct by summarizing their distinguishing characteristic. So the distinguishing characteristic of objects or of resources is that of all their essential characteristics, and they can be conveyed in a message. So they can be transferred, communicated within a message. And a resource in that sense can be described or designated by its metadata. And the thing is, if I ask on the web for the Eiffel Tower, of course not the Eiffel Tower will be delivered, but information about the Eiffel Tower. It means a representation of this object of the real world will be delivered and will get back to me. So metadata is an essential thing there because it describes for me the object I am talking about. So it's the same. The real data is inside the can, but the label that is on the can is the metadata, and that describes what is inside the can. So to put this in our life cycle, we have here an identifier identifying the Eiffel Tower. And if we access the web with this identifier, what we get back is, in the end, a representation of the original object that delivers information about this object in the form of metadata that describe the object. And this is sufficient for talking about the object. So this is the meaning of an identifier or a uniform resource identifier in the web and also in the semantic web. In general, the concept of a uniform resource identifier combines two things. First thing, it means an address. It's the Uniform Resource Locator. And this address denotes where a resource on the web can be found by stating also its primary access mechanism. But the problem with addresses, as also for real people's addresses, is this address might change during lifetime. But on the other hand, a uniform resource identifier is also a unique name. Therefore, it denotes the identity of a thing. And therefore, it's persistent. So it's a persistent identifier of a web resource by giving it a name. And this name doesn't change during the life cycle. But a name, of course, as in real life, is not sufficient for finding things. You have to know where the thing is. And as it's possible that the thing moves around, you have to ask somebody for the address. So if you have a name, then you can ask a so-called naming service and ask for the address of a thing. And then you get back the uniform resource locator, and then you can, in the end, access this thing. So the URI combines both concepts, the address and as well the identity. In general, the syntax that is required to encode an URI is pretty general. As you can see here, there is fixed encoding according to a US ASCII standard, and there are reserved characters that have special functions and permitted characters and not permitted characters. Now, there is also a standard that refers to the universal character code, to the Unicode, and there it's possible also to use international symbols. So symbols that are not in the US ASCII encoding, for example, as you can see here, where you have an Arabic URI that is also now possible. In the end, the schema, how the URI is built, is pretty simple. You start with a schema that describes the primary access mechanism and the protocol that is used to receive or to get the address, to get the name. Then there are mandatory and there are, let's say, optional parts that are here in brackets, like, for example, the information about username and password, the information about port numbers to use, or a path name, or a query string, or a fragment identifier. Mandatory or essential is the access schema. Then there is a separator, as you can see here, and then after the separator there comes the host name. And after the host name there might come an access path and also the file name of the document that has to be retrieved from the file server. And after the file name, also additional parameters can be transferred and communicated within a query or specifying a special part of the document. Okay, so in the semantic web, you are describing things with the help of URIs that are constructed in the way like URIs in the World Wide Web are to be constructed. But the problem is sometimes you want to refer to things or to resources that don't have an URI up to now. So you have to come up with an URI by yourself. And there, of course, you should obey a few rules. For example, you should avoid overlap, so always use your own website, for example, to specify information about yourself. And you should enable documentation to be at the same place as the resource you are talking about. So, it's not sufficient in the end that I create a URI for myself. I should also describe myself. So I should provide a resource with a representation of information about myself for documentation, as you can see here. So for example, I myself, I cannot be transferred via the HTTP protocol, but information about me can be transferred. So for example, information might be available at the URL that you can see here in the file Harald_FOV_RDF. And within that informational file, there is also a tiny fraction that identifies me, myself, and this is the fragment identifier, a hash, and then me, and this means this is me, and information about me can be accessed in the file that is really here transferred as Harald_FOV.RDF. But we will come back to that later on. Next, we want to talk about how to encode and represent facts and simple knowledge on the web. But this will be part of part 2 of this lecture, Basic Architecture of the Semantic Web.